Hello everyone, this is Jeff Z. So today I'm going to share my learning experience of the LeetCode problem number 242, valid anagram. It is an easy problem. Let's jump into the description. Given two strings S and T, write a function to determine if T is an anagram of S. So it gives in some examples of what anagrams mean. Um, so anagram is you have anagram S equals to anagram, T equals to NAGARN or AM, sorry. Because they have the same amount of uh, letters and they have the same letters, same amount of letters, so it's true, but in a different order, right? So example two is the same. S is RAT and T is CAR. So they are not exactly the same because you can find R here, you can find A here, but you cannot find a T here. So the output of this is false. So there's some additional requirement. You may assume the string contains only lowercase alphabets. So this is a very important information. I will tell you why it is important. So there's also a follow-up. What if the input contains Unicode characters? So this is different requirement. It's like extended requirement. Then it asks, how would you adapt your solution to such case? All right. So first thing is, this is my thought process. So first thing is, I thought, you know, the anagram is actually symmetric, but this is not true. Anagram is pretty much say you can find all the characters from this string. It exists in the the other string, but with different orders. So it's not necessarily symmetric. So symmetric will be different. It will be different requirement and different behaviors. So the first thing I can think after I understand what is anagram means, um, the very first time that I think is using the hash map, I can think of is using hash map. It's definitely doable. Um, I will. This is actually the code, but I will explain this later. Um, and I after I implement this, it's just I check the standard solution, the LeetCode solution. Uh, it actually shows that it's using array. I can show you later. Um, and one of the condition is it's use fixed size array. The reason is one of the condition above is actually it only contains lowercase alphabets, which means it's at max it will be 26 letters. So you can use a fixed size of array. So in this case, compared to the hash map, the array solution um, will be O1 constant space complexity. So I can go through both of the solutions. So let's go to the hash map solution. So first thing is in order to compare these two S and T, in order to make sure that S and T they are anagram each other, one of the thing is we need to make sure they are not empty. Sorry, they are not no, not empty. Yeah, so they are not no, and also um, if they should have the same length. If they are not in the same length, that means there are definitely some characters which in the CS doesn't exist in T or vice versa. Um, then after this simple check, it's like a edge case check. Um, or jump into the S. Basically, we will get the length of the string, one of the string, either S or T. Then I created this hash map, and the key is actually the characters, and the value is how many times the character occurred. So, and then in this case, next we loop the entire string, both S and T. So just to say, if there is a if there is a characters, the current character, it doesn't exist in the map. We'll just put it into the map, set to 0, and then I'll do one more time to increment the number of occurrence, because previously it's 0. But if it's this is the put if absent function is one trick that we can do is, if it doesn't exist, then we'll put the key and values. If it exists before, this statement will be skipped, and it will directly go to the go to this statement. Same here. So we'll say if I can find if there in the T, the current character, it's not necessarily the same character, but we'll just find if there's a if there is a character in the T, not exist in the map, we'll basically just create this key value pair in the map, and then I will I will decrease the number. The reason being is I assume that if they are exactly uh, anagram each other, um, all the at the end of the loop, all the values in the map, it should be 0, because um, you assume that there are characters which appear in this S can be cancelled in the T. So if you understand this, you will understand the next statement is pretty much we go to each of the key sets. We go to each of the key to check, say, is this the value 0? If the value is not 0, which means they are not anagram, means that either T has some characters S doesn't have, or S has some characters T doesn't have. And then it will return 0, return false. And after we do this check, we'll say, okay, everything is 0, then we return true. So this is the algorithm, and in this case, the time complexity of this algorithm is on, because we define the map, and the map is pretty much storing this assume that S has all the characters. We basically store all the characters in the for S or for T for sure. And then the the time complexity we're talking about is we need to loop the entire string, which is on. Um, and the space complexity is what I just said, is you need to store the map. You need to use the map to store the S, string S, and the T. Okay, so I can talk a little bit about the next solution, which is when you have the condition, say, if there is a lowercase alphabets only, you can actually assume there are only 26 characters. You use this 26 size array to say I have this counter, and each of the index is actually the offset uh, ASCII of the characters ACE ASCII code. So you actually can do this is the same, and then the next is you define a 26 size array, and you loop the s and the t to say, okay, for let's say in this case it will say for anything that uh, you know in let's say in this case it will be anagram is 0, right? So a minus a is actually 0. So given the first use case, sorry, the first example, then it will be 0 at the 0 position, index 0. It's actually increment, and the t is the similar idea, but it's actually decrease, similar to what I have put here in the hash map solution. Yeah, so so the next thing is after all the loop, we assume that if they're anagram, everything should back to 0. Every elements in the counter array should be 0. Then in the counter, um, we loop every single count, every single element. It's the same concept that if you found anything is not 0, return false, otherwise return true. Yeah, so the time complexity, it's still being n because you need to do the loop of the entire s and t string. And the space complexity, we can consider this as O1 because it has 26 characters always, sorry, 26 size always in this int array. Yep, so for the follow-up question, if the input contains Unicode characters, how would you adapt your solution to such case? So I assume that if it's Unicode use case, um, either so you need to use the hash map solution for sure, uh, because it's not only 26 size anymore, but I assume that it may require some special treatment when you recognizing this is a special characters. So I assume that hash map solution gonna work is going to work for the Unicode character use cases. So if you think there's anything that anything is wrong for in my explanation, just let me know. Leave the comment below. I hope my learning experience is going to be helpful to you. Thank you for watching. See you next time.